Unit 1 lesson 7, so last radicals lesson we have. Okay, so now we're converting entire with an index of 3 or greater to mixed. Okay, so we're just breaking down the higher level ones. So we're focusing on cubic, fourth roots, all those type of things. A lot of these are going to come down to, I don't want to say guess and check, but kind of trial and error. I'm not asking to memorize your fourth roots, but guys, anybody in your calculator can figure out what the fourth roots are, right? We learned how to use that in our calculator, and you also can figure out, like, okay, well, what's 3 to the fourth? 3 times 3 is 9, times 3 is 27, times 3 is 81. Oh, so 81 is a perfect fourth root. Does that make sense? So like you can figure out anything that's a fourth root by just kind of multiplying a number times itself 4 times. Okay, but same thing with cubic. Again, here's your 1 through 10 cubic. I said knowing up to about 6 is pretty solid if you can do that. Remembering 6. All right, so let's look and see here. So an entire radical of index 3 may be expressed as a mixed radical when the highest perfect cube has been factored out of the entire radical. So complete the following. So cube 54. So we remember same type of idea. Like 54, what's half of 54? So again, that same strategy works for this. If you have this list here that we talked about perfect squares, you could half it, kind of start there for things to try. I'm not going to try 64. Well, that's just obvious, right? 27, that's the next one. 27 times 2. Okay? They're not all going to be that easy, but just the way to start it. So 27, 27, and then the cube root of 27 is 3. So cube root 54 is 3 cube root 2. That's its mixed, simple answer. Mixed radical, simplified answer. Questions or concerns? Just getting started? Okay. So, actually I am going to do this. I'm going to give you a note card after the lesson today, and you can put these on a note card and the squares on a note card just so you don't keep flipping through your book. You can just kind of take it with you when you're doing your problems, okay? A little bit helpful. Okay, so 6,000. Anytime you see something 1,000, what perfect cube are you going to use? Yeah, 10, right? We're going to use this one. Okay, so we're going to go 1,000 times 6. Cube root of 1,000, 10. Cube root 6. That's your simplified mixed radical. Okay, so let's look at 320, and let's go ahead and do what we talked about, like we're going to look at halfway. So half of 320, and this is a fifth root, okay? This is a fifth root. So fifth roots, that means this has to be pretty small. Because if I just go, like, just for example, if I just go 4 to the fifth in my calculator, I get 1024 already. So if it's fifth root of 320, it's going to be pretty small, okay? So what I'm saying is half of 320, now this is not the fifth root, so we don't need to move this, but half of 320 is 160. We'd be trying to find stuff like 160 or below. So what I would do is, because I know I'm going to start with smaller numbers, I would go like, what is 2 to the fifth? Start with the easy one. It's 32. Does 32 go into 320? 10 times. So that's what it is. It's going to be 32 times 10. Fifth root, fifth root. See, that's kind of a trial and error thing. Now, if you're like, well, what about 3? Well, let's check 3, sure. 3 to the fifth, 243. That's not going to go into 320, okay? So we know it's going to be 2. Fifth root of 32 is 2. Fifth root 10. That's your simplified mixed radical. Again, you can put fifth root 320 in your calculator. It should be equivalent to 2 times fifth root 10. Cube root of negative 16. Can we do negatives in a cube root? Yeah, it's odd. If it's odd, it's okay. If you're saying, what are you talking about? That's not even. So we can have negatives. Negatives are allowed. 8 should be an automatic, is what I'm trying to say. I'm stumbling over my words. This is what you should be thinking right away when you see 16. 8 times 2. Cube root, I always do the one like, I always do a negative 8. I take the negative out if I can in a cube root. So then cube root of negative 8 would be negative 2. Cube root 2. So negative 2 cube root 2. Okay, any questions? So these are just higher indexes is all, higher indexes. Okay, so now we're going again from mixed to entire, so we're going backwards again. It's very important to pay attention to what the index is, because the index will tell you what to do to put it inside. If it's a 3, you cube it. If it's a 5, you fifth it to the fifth, like whatever you're pushing inside. Okay, so let's see what we're talking about again. Okay, so here's like a short example they have for you. So 1/2 cube root 80 to an entire radical. So what I'm going to do is I have to cube 1/2, which would be 1/8. Because 1 cubed, 2 cubed. Okay, so if I do that, then I have 1/8 here. Okay, and then what is 1/8 of 80? Or what is 80 divided by 8? 10. Awesome. So then you have cube root 10. That's the entire radical we just got down to. Okay, questions, concerns? Comments, complaints? Not yet, Yankee? Maybe later? Maybe, okay. All right, I'll work for it. All right, here we go. All right, so convert the following mixed to entire. So, again, if you're a little confused, that's a 4. I need to do 2 to the 4th. Two to the 4th is 16. So I have 16 times 3. So I have 4th root, sorry I ran over the writing here, of 48. That's the entire radical there. Okay, try these 3 here. Try these 3. Let's see how you do. I'll pause the video here. Okay, let's just go through. So again, this is the index. So that's what we're going to be doing with the mixed radical here. So we're going negative 4 cubed times 7 is all under the cubic radical now. So it's just that's the calculation you're doing. So negative 4 cubed, that's negative 64 times 7. And then that's going to be negative 448. And that's all. So some of you guys are getting overwhelmed with just like, yeah, you're doing a higher exponent than you're used to, but you have calculators. Okay, you're not supposed to memorize what 4 cubed is or 64 times 7 is. Yeah, Maddie? Brackets? Well, because you're pushing that number in, so that number is being cubed. Okay, good point. If this was an even, then we'd leave the negative out. Okay, but we can put a negative in because it's odd. You guys got that? Okay, so then here, this is all you have to do. 2/5 cubed times 100. That's it. So that's going to be 8 over 125, 800 over 125, which reduces. What's that reduce to? Did we get that yet? 32 over 5. Okay. So it's cube root 32 over 5, and that's it. Okay, so this is what I was talking about with Maddie. This next one, I can't push the negative in. This is what was on your exit card yesterday. Okay, I cannot put a negative in to a even root. So this negative just hangs out. It just stays right here. Then I go 4th root 3 to the 4th times 2. That's all I can do. Everybody okay with that? Remember, again, cannot put negatives in an even root. That's what we talked about just starting the class, okay? So this is 81. Yeah, times 2. So this is what your answer is. Negative 4th root 162. Into an odd root you can, correct. That's why we did it on question B here, part B. Good. Okay, anything else? Okay, so now we're going to do an extension here. This is a little bit advanced stuff, so just see if you can stay with me. This is what you do in terms of if you have variables inside of a radical. Okay, I'll kind of show you the longhand way, and I'll kind of show you an easier way, okay? So what I would do is, there's 6 x's in here, right? If we go back to 9, let's just talk about the square root of 9. This has nothing to do on the board, okay? What does 9 break down to? 3 times 3, and then we take 2 3's out, and they're 1 3, right? Everybody understand that? Square root of 9 is 3, we know that. Okay, so how many groups of 2 are in 6? That's why it's x3. There's 3 groups of 2 in 6. So if you're like, what are you talking about? Okay, look. 1, 2, 3, 4, 5, 6. That's x to the 6th, correct? This comes out as a what? An x. This comes out as a what? An x. This comes out as an x. How many x's? 3 of them. So you're looking for pairs. Everybody understand that? Here's the shorthand way. You can figure it out by dividing this number by this number. Because this tells you the groups you need. So if it's cubic, we don't need groups of 2, we need groups of 3. What's 15 divided by 3? That means there's 5 groups of 3, so that's your answer. Okay, so you can take the exponent divided by the index. We'll talk about what happens when it's not even. Okay, they're not always nice and smooth. Okay, 4 divided by, so it's 2. 10 divided by 2, why 5, yep. These are the same, we just do them separately. 8 divided by 2, A4. 6 divided by 2, B3. Am I going too fast? Are you following me? I'm just doing division of the exponent to the index. 24 divided by 3, x8. 6 divided by 3, y2. Okay, so now we're going to talk about when it's an odd. Okay, it's very simple. Okay, when it's a 2. Okay, this is why. You either have 2 options. You get 1 x left behind, or all the x's come out. Okay, you get 1 x left behind, or all the x's come out. So what I'm talking about, say I have x6, all x's came out because it was even. Here, right here, x4 divided by 2, all of them came out. When it's odd, what's 5 divided by 2? That 0.5 stands for an x staying inside. Okay, so this is why, if you're not following me, if I have 5 of them, this comes out, left alone. Doesn't have a partner. So 1, 2, x2 with an x inside. So what I'm saying is when you do the division, if you like division, 5 divided by 2 is 2.5. If you get a 0.5, that means a guy got left behind. He didn't have a friend to be a whole. Okay, so this is x4, this is x2. Your answer is x2 root x for that one. Okay, so let's look at these ones here. We'll do the square root ones first, and then I'll see how good you guys are with fractions on C and D. So what is 7 divided by 2? Yeah, 3.5, so it's x, it's A3 with 1 left behind, 3.5. Is that making sense at all? I know it's weird. You got variables, you got radicals, a bunch of gross things you don't like. I understand that. Okay, so T9, 9 divided by 2 is 4.5, so T4, 1 left behind. Okay, so how about 5 divided by 3? What would that one be? What's that? 1.6 repeating, good job. So that means that 1 came out, and then 0.6 as a fraction of 1/3, what is it? What's 0.6 repeating as a fraction of thirds? Like is it 1/3, 2/3, or 3/3? 2/3, that means 2 left behind. Okay, if you don't know what I'm talking about, look. 1, 2, 3, 4, 5. This guy came out, These two are left behind. So what happened was there's 2. So 2 divided by 3 is 0.6. That's where the 0.6 repeating comes from. Okay? So it's going to be x cube root x squared. 2 x's isn't enough to get out on this one. It needs 3. Okay, so what's 7 divided by 3? 2.333. So how many x's were left behind? 1. Good. Because 0.33 is 1/3. 1 was left behind. Okay. Again, this is an extension. So if you're feeling overwhelmed, this is kind of like a little extra, but we do talk about this in Math 20 as well. All right, here we go. We're going to break these ones down. And we have 2 more examples is all. All right, let's get this guy going. All right, so convert the following entire radicals to mixed radicals in simplest form. So we have variables. We have some variables with some numbers. Okay, so x6, square root, what's 6 divided by 2? x3 comes out. 5 divided by 2? 2.5, so that means a 2 comes out, 1 left inside. 2.5. One guy was left alone. Okay. Now let's break down 18. So what's 18 break down to? We're doing square roots. So what perfect square is going to 18? 9. So this goes 9 times 2. Okay. And then times the x3. What's the 9 come out as? Okay. What's 3 divided by 2? 1.5. So 1x out, 1 left inside with the 2. 3x root 2x. So the 9 came out as a 3. The 2 is left inside. 3 divided by 2 is 1.5. So 1 and your 0.5 left inside. All right, 32. 16 times 2. y7, z8. What's 16 come out as? 4. Okay, so I'll wait for the 2 here. What's 7 divided by 2? 3.5. So that means 3 out, 1 in, right? Okay, let's do the z first. What's 8 divided by 2? 4. So that one's a nice, smooth z4. So what was left behind? The 2, a y. Because the y was 3.5. All right, last but not least, we've got a cubic now, so we're looking for groups of 3. Okay, 40, 80 times, or it's not 8, 8 times 5. Why did I pick 8? Because 8's 2 cubed. Okay, I have an x4 and a y9. What's the 8 come out as? What's a cube root of 8? 2, right? So I have a 2 out. We'll leave the 5 in here. 4 divided by 3. It's 1.33, so that means that 1's out, and 0.3 stands for 1 in, 1/3. 1 out, 1 in. If you're struggling with that, you can draw them out every time if you want. Circle 3 and take that one out and see you have 1 left over. It's completely up to you. 9 divided by 3, even 3, so the y is all the way out. There's your answer. Okay, and last but not least, we're going from mixed to entire. Mixed to entire. So we're just pushing it in. So we're pushing this in. So that's going to be 2 squared times x cubed. That's a 2 root, index 2, I mean. So this one simply is 4x cubed. Okay, so this one is a variable, so we have to square it. So a squared squared. Here's your exponent rules from Math 9. What's this relationship? What do? Multiply. So that's an a what? A4. So I have A4 times A1, so it's A5. That's the entire. Okay. x to the 5th. So I have to go x to the 5th squared x, y. That's all in the radical. X to the 5th squared, sorry the handwriting's bad here. X to the 5th squared is, remember, 5 times 2, so that's x to the 10th. X to the 10 times x to the 1. What do we do here? Add. So it's x to the 11, y. All the things you thought you were done with are coming back. All right. Last but not least, a little bit of a harder one. We'll just kind of do it piece by piece. It's cubic. So I'm going to go, I have to cube the 3, I have to cube the x, and I have to cube y cubed. Okay, and then what's in there already is a 2 and a z, 4. So this is all under the radical now. Now we just have to simplify it. So 3 cubed is 27 times 2 is 54. So my numbers are done. X cubed, there's no other x's, so x cubed. Y cubed and then cubed again. 3 times 3, right? Cube, cube, so y 9. And there's no other z, so z 4. Oops, it's a 3. Okay. All right, well, that's it. Thank goodness. I think I wore you out.